that type of problem. So you should, there's actually not new theorems. There might be a couple things at the end of the last page, but we're still on the sections 10, 6, 7, 8. So wherever you were doing your samples before, if you've got some more space, let's do some more. An example of where you would use this would be like a swimming pool, for instance. We're just going to look at the swimming pool as a simple rectangular prism. We're going to find the volume, like how much water is it going to take. And I think it's interesting to see how much that weighs. I was kind of amazed by how much it weighs. Now this is a very simple rectangular prism that I'm going to have us do. Real pools, probably it won't be one level. Probably a deeper on the board end than it is just the swimming end. How would you do the volume of Seward's swimming pool?
Take a cup
and pour it. And how long would it take you to pour it? It would evaporate. But what shape is the Seward swimming pool?
It's like
it's a what? A key?
Yeah.
Okay, so there's a circle, but that's a bad circle. A circle, but it's not a complete circle, right? Instead, a key. Still wasn't real good. But, okay, so key, we've got part of this off, and then it goes down. We looked at it second period, and I thought that it went just straight down like that. It actually doesn't. Yeah, someone brought it up. I should add that to mine, but I didn't realize there was something. I don't know what you Googled. Or maybe even just Seward community or something. But that pool actually has a inset part there. There and there.
Oh, I know what that is. I'll try to get out.
Yeah. So these are the lap pools or the lanes, I guess. And then the diving.
It does.
So this is just, is it really deep here for the diving boards?
Yeah.
Is that 17?
And did you find an aerial view?
Yeah, I like that.
Okay, so what did you go to do that?
Just Seward pool.
Just Seward pool. Okay. And they, from the aerial, there's also kind of a piece here that's shown. What is that? That's the kiddie pool. What's special about the kiddie pool?
It gets shallow.
Yeah, it gets shallow to nothing. So if we were trying to do the depth of it, it would constantly be changing.
Remember when I couldn't touch the
So
ball?
it's really a wonderful shape, but as far as us trying to divide it into parts to find the volume of, it would be rather difficult to break it into parts and know what those measurements are. When you do calculus, you will have some techniques that will help you find the volume of something that is changing like that, getting deeper in a certain part, okay? Because it looks at kind of spinning a shape in order to create that three-dimensional object. So those are some interesting things for calculus. But wonderful shape, just a little bit hard for us to calculate. Have fun to swim in. So let's do the swimming pool, and then we'll compare what we get here to what it might be for the Seward pool. Do you guys remember the old pool?
I do, a little.
I don't remember how old that pool is.
Wasn't it
how
just
long
a
ago.
circle?
It was just a circle, and it got deeper in the middle. The diving boards, they actually, I don't think they had, yeah, they did have a board. They had a big tower that you would jump off of. So it wasn't so much boards, but it was a tower that was out in the middle.
So they just have a random tower sticking out in the middle?
Well, it's not random, but yes, that's where
You'd
it was.
swim out there.
That's where you, if you were diving or if you were going off the boards, you had to be able to swim out to the deep middle in order to go off the. So it's kind of interesting. Right, so you want a bonus, you find the volume of the swimming pool.
Can I just Google it? I wonder if
You gotta have the document or the information to get to that answer.
What?
All right, let's
What
try.
family owns it?
Yeah, exactly.
What family?
Yeah.
Is that what you said? I don't think any.
Is it an
family owns it.
organization or just the county owns it? Go to the courthouse maybe. Probably there's something.
Okay, so let's go back to our more simple example. Okay, we have just a rectangular prism we're gonna use as a just quick estimate for that swimming pool that I showed. We're gonna estimate the volume of water of the pool in gallons when it's completely full, and there's some information there. And the density of water tells us how heavy a gallon of water is. We're gonna figure out how heavy that pool is. All right, so rectangular prism, volume. What's the formula? Base times height, base area times height. And the base area would be 25 times 15 is your base area. Multiplied by 9 for a depth, that's kind of a deep pool. And you get, what did you guys get? You're sitting watching me?
Yeah.
I'm that entertaining. 3375, what are our units? Feet. And we're doing volume. Okay, cubic feet. Okay, we just found the volume. Now let's figure out how many gallons that is. It says 1 gallon is 0.134 cubic feet.
Times.
No, divide it.
Yeah, divide it.
See, here's where the debate comes in. I'm going to show you the tracks that I showed once in a while, but 3,375 cubic feet. The idea of the tracks is to cancel out units. You need like a numerator and a denominator of the same thing. So cubic feet, if I want that to cancel, I have to put cubic feet on the bottom in my conversion fact. So the 0.134 cubic feet would go on the bottom and 1 gallon on the top. So that is not a multiply. That's 3,375 divided by 0.134. Divide, because that much of a cubic foot makes every gallon. Divide by 0.134.
A lot of.
2518. Is that where the decimal is? Should we round up to whole number? 7?
Yeah.
All right. Gallons, approximately, I put. Okay, now, that's a lot of gallons. Water's expensive in Seward, so that probably costs a bit. And then how heavy is it? Okay, so take that number. I'm going to show tracks again so that you can just get an idea of how that works. So gallons, so 1 gallon is 8.33 pounds. So notice that you're just multiplying the numbers on top. So you were right, 25187 times 8.33, 209,808 approximately pounds. Ooh. How much is a ton? So how many tons is that? Yeah, that's almost 105 tons. Quite a bit. And that pool's not near the size of the Seward pool. But can you imagine how heavy that is with water? Now the issue, or one of the issues when they switched to that pool was the old pool was cracking because the ground was kind of sandy underneath and it wasn't holding the pool in place. So the pool was kind of sinking and cracks were forming, things like that.
Little kids get sucked in.
Yeah, little kids get sucked in. So, where would you experience this kind of thing in real life? I guess the sewer pool, in this situation.
If you were to huge or other liquid.
All right, here's another one, a real life thing.
I'm gonna live in that someday.
That's copyright.
Are we gonna get arrested?
Okay, we have a building here.
Pause it.
An art gallery. It's a 6-story square pyramid, kind of a unique building. The base area is half of an acre, and we're supposed to find the volume.
bunch of acres.
Now, what shape basically is that building? Square-based pyramid. So we have to find the volume of it. Why would you need the volume of a building?
So how much air to pump in?
Okay, how much air?
And liquid
Okay.
funds. Liquid
All right, one
funds.
at a time. One at a time here. Okay, the air would probably be important because if you're trying to put a heating or cooling system, you need to know how many cubic spaces of air you need to move around. People, possibly, we probably wouldn't stack them tight enough to make a good volume,
So I said in liquid form.
but as far as the fire marshal has to allow so much space for every person, so when they set what like the gym in the school here has a maximum capacity based upon the space that every person would take up. That's basically more the floor area, not so much the complete volume. So that would be maybe more related to just base area. But with the seats going up, it's not technically just the flat bottom. So that would be kind of an issue that someone would have in their job, needing to put a limit on how many people can be in the elevator or in the gym or in the gallery, things like that. All right, so let's see what we can figure out here. We've got different kinds of units. We have a 6-story pyramid. Base area is a half of an acre. Do you know what an acre is?
Yeah.
What's an acre?
It's 720.
It has to do with farming often, and the country miles, is a country mile, like a square mile, an acre?
No.
No.
It's not.
Okay, no, it's not. Okay, here's a square mile. Okay, 1 mile by 1 mile out in the country. This is called a section. Get some Nebraska stuff going on here. Okay, a section, 1 mile by 1 mile. 1 square mile is 640 acres. That's 1 square mile. Okay? Now, how big is 1 acre? I've heard the comparison is like the football field. A football field, think about how big it is. That's what 1 acre is, approximately. Okay. So, in Nebraska, we have a lot of farmers that you might be involved with. So they probably talk about the quarter. I'm going to go out and plant the quarter, or plant the 80, or something like that. You know what they're talking about. Okay, so when they say a quarter, what they mean is 1/4. A quarter is 1/4 in a fraction. 1/4 of a square mile. So if we divided this into fourths, that would be what they're talking about when they're talking about a quarter of ground. It's 1/4 of the square mile. Now, when you put a pivot on, lots of times they put it on a quarter because you can make the center and make a pretty good circle. It doesn't cover every piece of ground there, but it gets quite a ways. A lot of it is watered by that going around. If they have to stop it because like there's a house or some trees, something like that, you would be involving sectors. We talked about sectors, didn't we, so far? Okay, so there are jobs in agriculture where they have to figure out, okay, with this pivot going that far, how many acres of ground are they farming? Because the government programs need to report how many acres of corn they're planting or beans they're planting, things like that. So when they say they're going out to plow the 80, well, how much is a quarter if 640 acres in a square mile? 1/4 of 640 is 160, so a quarter is 160 acres. So an 80 would be half of that. Now, it's maybe not perfect like this, but that would be an 80 acres. And if they even have a half of that, they would be farming 40 acres. And you can keep breaking it down or whatever. But I would say probably farms maybe wouldn't currently go any smaller than 40 acres just for the average farming. Okay? Any other things come to mind? I'm trying to think, what farm things can I tell you about? Well, how many of you live on a farm or, I guess, are involved in a family that does farming? Okay. Quite a few? Right, quite a few. So you've heard them talk about acres and the 80 and the 40 and things like that. Okay. So there's some site information as a good Nebraska community person that you should be aware of. All right, so our base area is half an acre. So the bottom of this building is like half of the football field. And how tall is it? Let me flip to some more details. The story, a story is 10 feet about. So let's figure out what our volume is on our pyramid. Okay, the base is a half of an acre. What can we do more for that? It says 1 acre is 4,840 square yards. So what's a half of an acre going to be for my base area?
Wait, how long across is the
If an acre's that much, can we do half of that?
Yeah.
Half of 4,840 would be 2420. What's our unit? Square yards, it says. Okay, so that's the area of the base in square yards anyway. Now we need to multiply that to help us get the volume. So we need to figure out what's the height of this building. What's the height of it? What's it tell us? 6 stories. A story is about 10 feet, so that would be about 60 feet. But notice I've got feet and I've got yards. They're not the same. Okay, let's change the feet into yards. How many feet in a yard? Do I multiply or divide them? Okay, let's go 60 feet. Do I put feet or yards down here? Feet to cancel. 3 feet, 1 yard. It's not multiply. It's divide. So 20 yards. All right, let's find the volume. We've got the units the same now. Volume for a pyramid.
1/3 area base times height.
1/3, the area of the base was 2420 times the height of 20. So what do we get for our answer there?
161.
Is there a decimal there? What's after 2 3s? After 2 3s? If I'm going whole number, that would be where it stops? Okay, and our units are square yards, our cubic yards. We just did volume. Okay, so there's one answer. Let's make sure we got that right. Volume of the pyramid. Okay. Now let's convert it. I'm making sure that we did it right. Let's convert it into cubic feet, because that was the other part of the directions. Do it in cubic
multiply
feet.
by, no, because it's
Times by what?
Oh, yeah.
Okay, let's see. We're talking about a cubic yard. So a cube, okay, that is 1 yard by 1 yard by 1 yard. Now if I want to do that in feet, how many feet is 1 yard? 3 feet. 3 feet. So for the bottom, we would need 9. And then 3 rows of that. So wouldn't 1 cubic yard be 27 cubic feet? 3 times 3 times 3? So nothing with a 12 or a 3 or a 9. We need to multiply or divide.
multiply, because we're getting smaller.
Okay, we're getting smaller units. There should be more of them. 1 cubic yard is 27 cubic feet. So yes, we multiply by 27.
435,591. 435,591.
depends, did you round off this or not?
No, I
No.
left it with
Okay.
poetry.
All right, so that's the difference. Depending if we rounded that, then it was 591. If we didn't, then it's the 600. Okay, so I don't know what I said for the directions. I don't think I said. Okay.
Of course.
All right, so as far as story problems, those were both volume. Now let's think back to the pictures to give you something to look at. What would a surface area problem be related to a swimming pool?
Oh, the cover.
Okay, the cover, that would just be one surface.
Paint.
Painting it,
Do you
when you
Yeah.
paint a pool, would you paint the whole surface area?
No, because you're not using tile.
You wouldn't paint the top. So it'd be like lateral area and one base. Okay, if you're tiling it, where's tile usually? Is the floor of the swimming pool tile?
That
Yeah.
thing.
Yeah, it's usually that pokey kind of stuff. I'd say maybe it's not tiles. So if you were tiling a pool, it's probably lateral area only.
If it were my pool, I would
If
have.
you're cleaning it, that would be another lateral area and one base.
Slippery pool would be.
Tell me what.
No, that's the fun
Okay,
of it.
chemicals, I think that would be related to volume, because that's involving how much water there is. Okay, what would be a story problem related to our funny-looking building? What might be a story problem related to surface area? Okay, give me ideas. Malia? Okay, something about the windows. How many panes of glass do we need?
Wait, are we doing surface area?
Windows? We're thinking surface area. And the windows, would that be complete surface area?
No, it's not.
Right, I would say it's just lateral from what we can see on the picture. Daniel?
Well, maybe like on the sides it needs a certain amount of steel beams every certain square feet.
Okay, so maybe you're going further, once you get it covered with glass, the support things that you need there, the beams, could be involving ideas, surface area. Okay, right? Is that what you were thinking too? What was your idea?
How much time would it take to however many?
Right, that would be related to what she was doing then, right? Okay, so you can see where some story problems can come up related to surface area instead of volume. All right, so the other thing I want us to look at is, you know those problems where we're doubling the side, what happens to the surface area or something like that? We're gonna do a little bit of figuring out what happens to the volume. So I'm gonna give each row 3 measurements, length, width, and height, of just a rectangular prism. And I want you to find 2 things. What's the surface area of it? What's the volume of it? Okay, using the 3 dimensions as length, width, and height. It really doesn't matter which measurement you put where, it'll be the same surface area and volume. So as soon as your group gets it calculated, I'll put a graph on the board and you're supposed to enter your information. First row, your prism is 6 by 4 by 8. This row is 3 by 2 by 4. This one is 9 by 6 by 12. This one's 12 by 8 by 16.
Maybe I said 30 problems.
And you guys get 24 by 16 by 32. Volume and surface area both. Okay, calculate.
92 blanks,
Blanks,
huge blanks, cubic blanks.
Do about
No, that's what Chris did. Chris, that's not the volume. No, yeah, that's the volume.
Don't question me, Toby.
4 times 8 equals that.
20 times, what's 8? Is that 8?
24.
10.
Chris, did you do the blank square or whatever?
24.
When you have your numbers, someone from your row come up and put them in.
Chris, what did you get from Chris?
208 blank units.
Yeah.
Yes.
That's maybe just your lateral.
I'm gonna check that, so. So, yeah.
Chris, does that look right?
Yeah.
Okay.
Should have put white.
Where did I get 240 then? What did I do wrong?
Yeah, 468 surface area.
And then volume.
Yeah. What did you get paid?
That volume.
I think we did pretty good, guys. Okay, I'll go. That was yeah. I checked the check. Alright, so the heat volume, we all get, yeah, 288, right? Agree? So you're right? Okay, I'm marking that one. Wait, what did you get? 1, 2, wait, no, it's that. For what?
Yeah.
I'll write it down if you find something, let me know. Actually, I'll figure it out, I'll see Jack.
It's okay, Bob.
I'm just gonna read it.
I can hate you.
Yeah. Well, correct it, yeah. Think about happiness. Like how much money you get going. And we have a weekend. Puppies are really cute. Puppies are really cute.
How much you have? 12 by 6 by. Oh, you mean 12?
All of my. I'll be 16.
On Cinco de Mayo.
We're having a Yeah.
Okay, we've got all our numbers up here. Let's see if we can draw the conclusion. Now, some of you noticed how I created the numbers that I gave you. I know some were talking about that. I used this, the second one actually, as my base shape that I created. And then I took every side times 2 for this group, every side times 3 for this one, times 4, and this group got times 8. Okay? All right, so let's see what relationship we can figure out. Okay, if I took every side times 2, okay, what happened to the surface area? This is the original surface area, 52. They got 208. Was it 2 times as much surface area?
Oh, no.
It was 4 times.
It was
Four.
4 times as
Four.
much. Okay. You added 3 more on, but 4 times as much. What happened to the volume?
8.
Yeah, multiple by 8, yeah.
8 times as much? Okay, why did it get so big?
Can we take a picture of this when we're done?
Yeah, when we're done. Is what I'm writing making sense?
Yes.
Okay, so to get this one, up here please, again, focus so I can be heard. Okay. We took each side times 3. Okay, so the surface area got how many times bigger? 6 or 9. How can you do this? Divide. Got a calculator?
9.
468 divided by 52, I think you'll find is 9, not 6. Okay, how about this one?
27.
That was 27 times as much. So you figure out where those numbers are coming from. The 9 is the same as
Area.
3 squared.
You bless yourself.
We've done things like if you change the 2 dimensions, the area changes by squaring that, because areas are 2 dimensions. So if you multiply by 3 this way and by 3 for the height, you're multiplying in area terms by 3 times 3, or 9. Now volume, how many things do you multiply to find volume? It's typically 3 dimensions because it's cubic units. So if we multiply by 3 one way, and then 3 another way, and then by 3 again, we multiplied by 3 times 3 times 9, we made it 27 times as big. So I'm going to write this as 3 cubed. Does that work back here then?
Yeah.
8 was the same as 2 cubed. 4 was the same as 2 squared. Okay, so let's see if we can do this more easily then. For this row, every side was multiplied by 4. So the area should be multiplied by 16, double check it. 52 times 16. Okay, and then this one multiplied by 64. 24 times 64. Comes up in a lot of homework there, yeah. 4 squared. Okay, now this group that had such big numbers, how many times did we multiply the sides? 8. So this surface area should be multiplied by 8 squared, or 64 times as much. And this should be multiplied by 8 cubed.
512.
So multiply by 512. 24 times 512. All right, so if I tell you what to multiply every side by, what's the surface area going to get multiplied by? By A. Why am I using A? It's what they had in the explanation. Volume would be multiplied by A cubed. Now let's do one that's not just a straight number. Let's compare, let's see, the top one and the third one. So we'll compare the 6, 4, 8 and the 9, 6, 12. Okay, what I first need you to tell me is, what are we multiplying the sides by? Not times 2. It's a fraction.
1/3, 1/3. 1/3.
Okay, 9 divided by 6 is how much? 1.5 or 3 halves? If I do a fraction. If I take 6 times 1.5 or 3 halves, it makes 9. Okay, so every side is multiplied by 3 halves. So what should happen to the surface area? Multiplied by fraction, 9 fourths. We had problems though we're in fractions, is why I'm doing it that way. Multiplied by 1.5, multiplied by 1.5 squared. Volume would be multiplied by 27 over 8. Where are we getting that? We're just cubing this. And what's the number to write down here? What's 27 divided by 8? Or 1.5? 3.375. So whichever form is making sense, the volume is going to cube what you do to every side. The surface area is going to square whatever you do to every side. Write it down right. Okay. We've done that same kind of theorem more than one time. you can go back to those problems where we have to find the missing, like, volume. If I know that, let's see, the volumes are gonna be in the ratio 27:8. If the beginning volume was 192, what's the volume of the other one? When you cross multiply, does that come out with the 648? Or let's see, maybe I've got it upside down. 3,000. How about 192 down here? Sorry. I had the volume of the smaller one. And I need to find the volume of the bigger one. Does that one work to be 648?
Yes.
Trying to make a connection between some theorems that we had done. Is that making any sense? Let's see what problems I have on the smartboard if we got what we need to for our assignment. Okay, the length, width, and height of this oblique rectangular prism are doubled. What's going to happen to the volume? Multiplied by 8. And where are you getting 8? Doubling cubed because of volume. And I did go through and calculate each one, but I don't know that you really have to. If you know that it's 8 times as much. That's kind of proving what's going on there. Radius and height are multiplied by 4. What's going to happen to the volume?
Multiplied by 64.
Multiplied by 64, which is 4 times 4 times 4, 4 cubed. And there's the proof to come up with it. If the diameter and the height are divided by 3, what's going to happen to the volume?
Divided by 1.
Divided by 1, 27.
Or divided by
3 cubed. 3 times 3 times 3. So divided by 27. Or you could say multiply by 1/27. Sporting Goods store has exercise balls, standard size and a jumbo size. How many times as great is the volume of the jumbo ball compared to the volume of the standard ball? I mean, you could go through and find both volumes, but can we do it with what we're thinking? And how many times bigger did we make the diameter? 34 as compared to 22 is how many times bigger? 17 elevenths. Give me a decimal. 1.54. 54, blah, blah, blah.
Yeah, 5454, whatever.
Okay, so every diameter is getting multiplied by that. So what's the effect going to be on the volume? That cubed. So what is that cubed? Volume will be multiplied by,
27 over 8.
how about, give me a decimal.
3.379.
Okay, so the question, how many times as great, I could answer it by saying it's 3.375 times as much. If you want to give a fraction, that's fine also. What are you getting? I wonder if it's a matter of rounding. Was this 3.375 just 1.5 cubed? If you do the 1.545454 cubed, is it 3.6 something? Okay, 1, blah, blah, blah. Okay, so it's a matter of are we rounding or are we not? It probably would be best not to. So I think this answer that someone gave me was rounding this to maybe 1.5.
There was that.
It was.
Come on.
So a little bit more accurate was better. Okay. Does that help make some sense out of, does that help make some sense out of some earlier theorems we had? Where you're doubling it or tripling it with the area and the surface area. Now the volume is cubing whatever's going on. Okay, now you have a couple sentences in your notes. Did you get those filled in? Okay, the very last page.
Yeah.
Okay, If the side of a cube is multiplied by A, what effect will there be on the volume of the cube? The volume's gonna be multiplied by A cubed. Don't just say volume is A cubed. No, volume is multiplied by A cubed. If the radius of the sphere is multiplied by 2/3, which I didn't do up here, what effect will there be on the volume of the sphere?
Volume times 8/27.
Volume will be multiplied by 8/27, which is the 2/3 cubed. Okay, the assignment that we're doing is from the same pages as yesterday, but some of the problems we did not do. Yeah, I guess it's scribbled enough that you can tell what's going on. All right, page 701.
Because it was quicker.
I don't have any quick.
None at all.
I got some today.
There you go. I got it. Here goes Noah's always up here.
Okay, I want to clarify on the very end of this, and I did change it over there, but not on the backpack yet. The very end, I think I made a note about just volume. We need to do combo shape surface area practice anyway, so we'll do the whole thing there. I originally had a note just to do volume, but we need to just do exactly what's up there. Both surface area. They're the same pages as yesterday, but different problems. So it's more the story problems or the effect of changing